centric loading. Okay, the position of the centroid and neutral axis are the same. Okay, I repeat again, for symmetric centric loading, the position of the centroid and the neutral axis are the same. Okay, so the neutral axis is dependent on stress field. Right? The centroid is depend on geometry. Yeah, they are not the same, quite in the same way. Okay. So I want to build up the information that I'm giving you. Okay. Next, I like to define. Okay, I like to define what do we mean by symmetrical centric loading. Okay, I want to define what do we mean by symmetrical. You've seen these words before. Okay, Eugene always say symmetrical centric loading. What does it actually means? Okay, why is important? Because I got it wrong until recently, until like 4 years ago, then I got it right. Okay, again, 4 years ago, I was 46 years old. Okay, you guys are half my age. Get this thing right. Don't be like me. Always making mistake until I'm 46. Unbelievable. Yes or no? Okay. So what do we mean by symmetrical or symmetric loading? Okay, what do we mean by symmetric? Right. So we're going to look at this. What is symmetric loading? Okay. What do we mean by symmetric loading? Okay. So I'm going to draw two structures for you to have a look. Okay. So I'll draw the axis. X, Y, rotation about Z. Okay. So both beam I'm going to draw is simply supported. Okay. So this is our point A. This is our point B. And next, that is our point A. This is our point B. Okay. So on the left-hand side, this is how our load distribute. So the distance from here to here is A. The distance from here to here is A. Okay. So that's our left-hand side. On the right-hand side, we have a slightly more complicated loading situation. Okay. So we have omega over here. Omega the same. This is also omega, and we have a py. Okay. So we have condition number 1. Condition number 2, and then the distance from here to here is L over 2. From here to here is L over 4. Okay. Can anyone tell me which one is symmetric loading? The left-hand side condition number 1, or condition number 2? Anyone? Online. Come on, you answer this question then. Make sure you condition
Jay,
number 2.
both are symmetrical. Like if we divide the our distributed load in a single load, that will also be applying on L4 on the other side, isn't it?
Michael say both. JSA, you say 1. Gunpreet, you say 1 or 2? Both.
No, yeah, I'm saying both.
Both. Okay. Both is correct. But why? The why is wrong. Okay. Both is correct. The why. So both is correct. Okay. So it has nothing to do whether is it symmetrical or unsymmetrical loading, has nothing to do on how the forces are applied. Again, I repeat. So whether is it symmetrical loading has nothing to do with the point or distributed loading condition. Okay, both of them are symmetrical loading. Now you get confused. Then where does the word, why symmetrical? Yes or no? If you look at the word symmetrical, right? One is symmetrical in terms of loading, condition, and forces. Right? So if I split a line and we call it the YY axis, A, right? The loading condition on the left is the same as the loading condition on the what? On the right. Okay. Whereas in condition number 2, if I draw a line on the center, I call it YY, the loading condition on the left is not the same as the loading condition on the right. And yet, we say both of them has what? Symmetrical loading. So symmetrical loading has nothing to do with how the point load and the distributed load are contributing to the loading condition. But what is it dependent on? So the next thing I'm going to do, right, we are going to look at the cross-sectional view. Okay, the next thing we're going to do is we're going to look at the cross-sectional view. Okay, we're going to look at a cross-sectional view. So I'm going to draw three cross-sectional view. Okay, I'm going to try to sketch the best I can. So this is number 1. This is number 2. And this is number 3. Okay, and then I'm going to draw transformation now. This is on y-axis, z-axis, rotation about x. Okay. And then I'm always going to call the top right-hand corner all this our alpha, beta, point I, point J. Then I'm going to sketch for you the centroid. Okay? And all of them have a moment, right, apply in the Z direction. Because all of them have only moment in one direction. Okay? So anything on top is compression, anything below is what? Tension. Right? So now, so I call this section number 1, section number 2, section number 3. Okay. The formula we use is stress X is equal to minus mz over izzY. Okay, I'm going to ask you a question. Okay, I want you all to think about it. Now, which cross section is under symmetry loading?
I think 3.
3. Okay, so we have 3. What else? Any other guess? Now you say, why do you say 3?
Because it's symmetrical on both sides, on the y direction and the x direction.
So on the y and z direction, the geometry are symmetry. Yes. So that's why you pick number 3. Anyone else? All 3 is axis symmetry. All, okay? Yeah. The answer is all are symmetrical loading. So some of you, holy crap. How is it all is symmetry loading? Yes or no? Okay, I'll show you why. So if we were to find the stress at alpha and beta, we call this Y1. Likewise, over here, this is also Y1. Over here, the distance to alpha and beta is Y1. So if we were to apply the formula now, okay, if we were to apply the general formula, where stress X at point alpha is equal to minus mz over izz multiplied by what? Multiplied by y1. And for this case, we also say that stress X for point beta, what's the formula? It's exactly the same, right? mz over minus mz over izz multiplied by y1. So for this case, so therefore, stress X alpha is equal to stress X beta, right? So when that's the case, it's under what? Therefore, it's under symmetrical loading. Likewise, okay, likewise, how I wish, okay, I can squeeze a bit. I think I can squeeze a bit. I want to squeeze. Yeah. Likewise, if we have stress xi, it's so over here for stress xi,